Hello everyone, welcome back to Math with Allison. Today we're still working on derivatives, so specifically we're going to be talking about the mean value theorem. So let's go ahead and dive into it. Question, what does the mean value theorem do? So let's go ahead and look at the definition. We have let f be continuous, so continuous function, on some interval a to b, and differentiable on a to b. That means we can take the derivative of it. Then there exists a point C in the interval a to b such that f prime of c, so the first derivative evaluated at c, is equal to f of b minus f of a all over b minus a. So this is the official definition, but let's work out what it actually means. I have kind of a fake little function right here, and what we're going to do is first define our interval. So let's go ahead and say this is our a and this is our b. So given our a and our b, we can find the f of a, which is the function defined at a. That's going to be this point right here. And we can also define the function at b, which is going to be that point right here. So notice when we try to find slope, it's going to be change in the y over change in the x. So in our case, we're going to take our corresponding y value, so f of b minus f of a, and we're going to divide that by our x values, and that's going to be b minus a. And notice that is exactly what we have right in here. And so what this is doing is defining the slope between these 2 points. So I'm going to write that on top. This is a slope. So what this is saying is that we can find the derivative at some point c, and it has the same exact slope as this one. So if I were to just take this line, I'm going to copy it, and I'm going to go ahead and paste it. That means there's some point along here where it lies perfectly tangent, and I think that would be right about there. And so this right here is going to give us our point C. Remember that the derivative defines the slope of the tangent line at any given point. And so this right here is going to be our corresponding C value, where this is equal to f prime at C, because this also defines a slope. So that's what the mean value theorem is actually saying, that there's going to be some point C where it has the exact same slope as there is between those 2 points. So there's an alternative way to see this formula, and that's where people just multiply over that b minus a. So you might see it both ways. Okay, let's go ahead and try an application of this. So determine all numbers which satisfy the mean value theorem for the following function, f of x equals 2x squared plus x minus 1 on the interval 1 to 3. So what we could do first, you can set this up in multiple ways. I'll do it one way first. Is first we can go ahead and calculate that f of b minus f of a. So our b value is going to be that 3, and our a value is going to be the 1. So let's go ahead and calculate f of 3. So here I got a value of 20. Let's go ahead and calculate our f of a. Alrighty, so we got 20, we got 2. So let's go ahead and plug this in. We have f of 3 minus f of 1 all divided by 3 minus 1. Okay, so we found that part of the formula. And remember, the other part is that we have to find the derivative. So let's go ahead and calculate the derivative now. We have f prime of x is going to be equal to, and we take the derivative, 4x plus 1. Now remember, we're trying to find all the c values, which means I have f prime of c, and this equals 4c plus 1. I just went ahead and replaced my input, right? So what I want to do now is I want to set these two parts equal to each other. We have f prime of c, and we also have f of b minus f of a, blah, blah, blah. So what we do is we set these equal. And we found a c value. Now, be really careful because this isn't us being completely done. What we need to do is make sure that this value that we got fits within our interval. In this case, it does. 2 is between 1 and 3, so we found all our c values, and this is going to be our final answer. Let's go ahead and try another problem. So now we have the function x over 1 plus x on the same interval 1 to 3. Like I said, you can do this in any order you want, so I'm just going to go ahead and flip the order. First, I'm going to find the derivative f prime of x. And in order to do that, I do need to set up quotient rule. So we have the numerator is x and the denominator is 1 plus x. I'll go ahead and set that up. Alrighty, so the derivative of x is just going to be 1, and the derivative of 1 plus x is also just going to be 1. So remember, when we do quotient rule, we do have to start from the bottom, work our way to the top. So that gives us 1 plus x. And now we have to subtract our other cross multiple, and that is just going to be an x. And then this is all divided by the denominator squared. And then notice here those x's cancel out. That's really nice. So we get 1 over 1 plus x quantity squared. So remember, we're trying to find f prime of c, so I'm going to go ahead and plug in that c value. And now we need to find that f of b minus f of a, blah, blah, blah. So we have our a is equal to 1, and our b is equal to 3. So I'm just going to plug both of those into the function. Okay, so I simplified it all the way down. We got c is equal to negative 1 plus or minus 2 root 2. So I'm going to write it up here. This is going to give us two solutions. The first one is c is equal to negative 1 minus 2 root 2. And the other one is c is equal to negative 1 plus 2 root 2. So again, what we need to do is make sure that these are actually in our interval. So we have two values, and we want to make sure they're between 1 and 3. One of them I can already tell is not going to be between 1 and 3, and that's because this one right here is going to be very negative. We have negative 1 minus that whole thing, which means we get to ignore it. Our other one is going to be negative 1 plus 2 root 2, which is going to be in our interval, and so this is going to be our only solution. So always make sure that we go back and check the interval, because that could result in an incorrect answer if we don't. Okay, we got one more here. We're going to try a trig problem. So now our function is x plus 3 cosine of x on negative pi to pi. Like I said, we can do it in any order we want. So let's go ahead and calculate f of b. So that's just going to be pi. So cosine of pi is equal to negative 1. So that's going to be equal to pi minus 3. Now we're going to go ahead and plug in negative pi. And so here we get negative pi plus cosine of negative pi is still going to be negative 1. And so now we have our two values. Let's go ahead and calculate f of b minus f of a. Okay, so I simplified that down. I got a value of 1. We like 1s. So now let's go ahead and calculate that derivative. So we have f prime of x is equal to, and we get 1 plus 3, and that becomes a negative sine of x. So if I rewrote that, I get 1 minus 3 sine of x. If we wanted, I don't know if all teachers actually require this, but f prime of c is equal to 1 minus 3 sine of c. I don't know if some professors let you leave it as x. It's the same idea. We're just solving for a value. So we're going to go ahead and set these two equal to each other. So we have 1 is equal to 1 minus 3 times sine of c. Subtracting 1 from both sides gives us 0 is equal to negative 3 sine of c. And I can divide by that negative 3, so I have 0 is equal to sine of c. Taking inverse sine of both sides, I get the inverse sine at 0 is equal to just c. And now we want to look for the angles at which sine is 0. So I'm going to go ahead and draw out the graph. So don't forget, we're bounded at negative pi and also positive pi. So I just remember that sine starts at 0. At pi over 2 goes up to 1 and then back down. And then it does that exact same thing on the other side. So there's going to be three angles here. We have negative pi, we have 0, and we also have pi. So let's go ahead and answer that. And now we want to make sure that they fit within the interval. So if I go back, we're between negative pi and pi, and it looks like the only thing that's going to fit is 0. The reason that we don't include negative pi and pi is because we actually don't include the endpoints. If we go back to the definition, it says right here that there exists a point C in the open interval a to b. That means we don't include the endpoints. So that means our only answer for that problem is going to be 0. So that's all I have for us today. If you enjoyed this video, I have many more like it, so make sure to check out my playlist. They're linked down below. Otherwise, please give this video a thumbs up and comment other problems or topics you'd like to see done. Thanks for watching.